Hello and welcome to Module 7, Connectivity Verification. So we're primarily going to cover two things, really, the ping command and the trace command. And the ping and the trace command come out of the ICMP protocol. So those are the two topics we will cover today. ICMP, ping and traceroute utilities, and how we can use them to troubleshoot network connectivity. Okay, so remember, I will ask you to take notes as we move along. ICMP, the Internet Communication Message Protocol, is really designed primarily because the Internet itself was not, it's the Internet Control Message Protocol, not communication, just for correction. So ICMP was created because the internet, when it was created, there was no management software that keeps track of how data flew across the network, which link was broken, or anything like that. So please write the first couple of the first three bullet points of the ICMP. So part of the ICMP is when we use the echo request, when we use the ping command. So when you ping a device, you are sending an echo request ICMP message to that device, the 192.168.30.1. And when the 192.168.30.1 receives that echo request, he will send back an ICMP message also, called the echo reply. So ICMP must be running on your devices to be able to do an echo request and an echo reply. Okay? All right, so when you are receiving, let's say, an echo reply, please write these four message codes from the echo reply from a device. So if you get a code with a 0, that means your network was unreachable. If you get a reply, say, with a code number 1, that means the host is unreachable. A code 2, the protocol, like maybe SMTP or HTTP, is unreachable, or the port is unreachable. All right. Remember, these are for IPv4. For IPv6, it's a little bit different, and even you got a little bit more codes. ICMP uses the TTL number that is stamped on every packet when it's released to indicate that, to let you know that your packet have died or did not reach its destination. The internet, when it was first designed, your packet will be able to, your packet was traveling across the network. So to make sure that the packet does not just loop around the internet forever, there has a time it has to reach its destination, and that time is stamped on the packet, called the time to live, TTL. Every time a router receives a packet, it's going to decrement the TTL number by 1. If you received a packet and the TTL number is 1, then you decrement it to 0, then what you're going to do, your responsibility is to create an ICMP packet and send it back to the originator to let them know that their packet TTL number has reached 0, which means your packet died. That means you cannot route the packet anymore. So, but it doesn't tell you exactly where the packet has died. When you do a ping command, the ping command will use the TTL number to make sure that your reaches its destination. And if it didn't, it will send back a packet saying to you that the TTL number has died. Okay, write these 4 bullet points down. That's important because you need to understand why you're doing it. ICMP4, ICMPv6, actually, also write this down, by the way, before I forget. ICMP version 6, that's for IPv6, has an improved improved functionality over the version 4. So it uses four new protocols as part of the neighbor discovery protocol. The router solicitation, your device will use an RS command to request, for example, the network portion of the IP address. And then the router will send you an RA, a router advertisement message giving you that information that you want. So when we're using Slack, the stateless auto configuration protocol to configure our devices, configure our devices with an IP address without the need of a DHCP server, you send out an RS and the router will send you an RA, then you'll get your network portion of the IP. And then what you do, you'll create your own host portion of the IP address randomly. So also you may use the network solicitation, DNS, and the network advertisement. This is like for doing the instead of ARP requests. So those are the four different protocols that is being used, part of the ICMP version 6. So here's the Slack versions. You send out so this is what we have discussed. RA messages are sent to routers to request the network portion of the IP, and then you get an RA from the router. Okay? And that's the RS. Okay. Now, when you get the network portion of the IP, like I said earlier, from the router using RA and using the RA, the router advertisement. So what you do is you create your own host portion and you got your IP address. So therefore, you did not need a DHCP server to configure your own IP address. So, but you need to find out that if that IP address that you randomly created, the host portion of the IP, nobody else picked that one, a duplicate one. So what you use is the duplicate address detection, DAT. So you send out a message and you say, hey, I picked this host portion of IP. Did anybody pick it? And if nobody did it, then that's it. Then you keep your IP address. That's what the DAT is for. All right, let's take a little bit closer look at the ping and the Traceroute utilities. Again, a good video to watch when you're reading it. This will go over how to use the ping command, what it's used for, the NS lookup, the netstat command. So this is a pretty good video to see some hands-on work with these utilities. All right, so when you ping command, you send out an echo, like I said, an echo request to the destination, and then the destination will send you an echo reply. There are three devices that you want to really ping or send out an echo request to. The pinging the local loopback, the default gateway, and a remote host. Let's look at each one of them and see what the difference is. Let's pinging the local, the loopback address. So when you have a TCP/IPv stack, part of the operating system, this is the one that does all the encapsulations for you, for your packets that you're trying to send from the application layer all the way to the network, or all the way to the physical layer. So when you type ping 127.0.0.1 for IPv4, or you type ping colon 1, what you're doing is at layer 3 of the OSI model, the TCP/IP stack, you're asking your computer to create a packet, stamp on it 127.0.0.1, encapsulate it into a frame, put it on the media, but don't send it out and loop it back. Bring it back, open the frame, and bring the packet back. So what you're doing when you are testing the loopback is you're testing the TCP/IP stack, this guy right here, to make sure that your computer has loaded the TCP/IP stack correctly. That means the local host knows how to encapsulate and decapsulate packet. So the first thing you want to do when you're checking connectivity is ping the loopback. If that's successful, that means your computer knows how to encapsulate and decapsulate packets. Okay? So write the first 2 bullet points for pinging the loopback. When you're pinging the default gateway, that's a router. Remember we discussed that on the last chapter? The router that takes you to the outside world. So you want to be able to see if you are connected to your router. So when you ping the default gateway, and if it's successful, your connection is probably outside. If you have a problem connecting to the outside world, one of the first things you want to do, like I said earlier, just now, ping the loopback first, then you ping the default gateway. If both of these are successful, then your problem probably is outside, from the outside connection. Okay? Take the first bullet point on this guy. So write that down, so you'll know what pinging the default gateway means. How do you get the default gateway? How do you know what your default gateway address is? Just use ipconfig, the command. All right, and it's written right in here. That's what you ping. This is your IP address, that's the mask, and you're pinging your default gateway. If you're pinging a remote host, that means you're pinging it outside. So you're sending a ping, 10.0.0.1 is going to ping maybe somebody else in here. It's going to go through your default gateway to the rest. So pinging a remote host is pinging somebody that is not in your LAN. And you will need to go through your default gateway. If you ping a remote host and it doesn't respond, maybe your router, your connection here is wrong, is misconfigured or down. So you ping your default gateway, that's the F1 first. If that's successful, then you can try to ping the remote. Now, if that still doesn't work, it could be that the router doesn't have the route, or maybe this guy is misconfigured. So that's something else that we'll need to worry about later on. Okay, now, Traceroute. Traceroute, you use that command in on your router, but if you are on a Windows PC in the command prompt, you use Traceroute. Traceroute goes through every hop and gives you information if it has reached it and how long it took to reach every single hop that your packet goes through as it traverses the network. So remember I said earlier that if you ping and your TTL number reaches 0, the remote device where the TTL needs 0 will send you an echo reply telling you that your packet has lost, but it doesn't tell you where in the network your packet failed. If you want to know exactly where the problem is, where the TTL number has reached 0, or where there's misconnection, so what you use the Traceroute. The Traceroute is going to tell you every hop that it goes through. And if you see asterisk, it indicates that the host has got lost. That's where the problem is. It will tell you every hop that you're going through. So please take the first 3 bullet points, because Traceroute will give you the round trip time, the time it takes to reach a hop and back. All right, so both IPv4 uses the TTL number that it's stamped on the packet, and IPv6 will use something called hop limit, which is really the same thing as the TTL number. Okay, so both packets on IPv4 or IPv6 are limited to how far they can go. Okay, so write that first statement. So Traceroute will use both of them. So there is your, well, when you are looking at ICMP, there is your codes. This is an ICMP packet that is sent back to you, for example, right? And if the code in here is number 3, then you know that the network, your computer will display the statement that says destination is unreachable, right? So these are more codes that you should be familiar with. Time exceeded, that's when you get timed out. That means the TTL number has reached 0. So please write these codes down, because I've seen them come up before. Okay, the ICMP codes. And that's it for this chapter. Okay, so it's pretty easy. So now that when you are using ping and trace out the traceroute commands, you know exactly what they are used for. All right, so take all the notes that I told you and please upload them. Upload them as proof that you have used this video, and I will see you in Module 8.